Hello everyone, let's start with the topic of today, that is the measures of variability. In the previous video, we have seen the measures of central tendency. Now let us see another method of describing a data set, that is the measures of variability. We know that the central tendency or average tells us where most of our data points will lie, whereas the measures of variability summarizes how far apart each data point lies. The different measures of variability that we will be seeing are range, IQR or the interquartile range, variance, and standard deviation. Moving ahead to range. The range tells us about the spread of our data, that is, from the lowest to the highest value. Let us consider an example. Suppose the values of a variable are distributed from 1 to 100. In this case, we can say that my range is equal to 1 to 100, or we can also say that my range is equal to 100 minus 1 or 99. So both the things we can use. One thing to note is that the range is influenced by outliers. We have already seen that the outliers are mostly present on the extreme points, right? So for example, if this 100 was changed to 1000, in that case, my range would have become 1000 minus 1 equals to 999. So the range is affected by outliers. Moving ahead, percentile, decile, and quartile are the terms that we frequently use in statistics. When we divide a data set into 100 equal parts, we get the percentile. We represent each percentile as P1, P2 up to P100. Similarly, when we divide a data set into 10 equal parts, we get deciles as D1, D2 up to D and D10. Similarly, when we divide a data set into 4 equal parts, we get the quartiles Q1, Q2, Q3 and Q4. Let us consider an example. To find the quartile, I divide my dataset into 4 equal parts. In this case, I have 8 data points. So, dividing my dataset into 4 equal parts, this will be my first quartile. I can say that it's Q1. 82 will be my Q2, second quartile. 87, Q3, and 90 will be my quartile 4. I can also say that my Q1 is equal to P25 or the 25th percentile point. Similarly, Q2 will be equal to the 50th percentile point. Q3 will be equal to 75th percentile point, and Q4 will be equal to P100, that is the 100th percentile point. Moving ahead, now we will see the interquartile range. Interquartile range gives us the spread of the middle 50% of the distribution. It is a very important measure of variability. Why? Because mostly we are concerned with the middle 50% or the top 50% of the data points. In that case, IQR comes into picture. IQR is simply calculated as Q3 minus Q1 or third quartile minus the first quartile. To find the quartiles, as we have seen, we divide the entire range into 4 equal parts. First part, second, third and fourth. The difference between or the range between Q1 and Q3, I call it as interquartile range. Interquartile range, if we see in a normal distribution, if this is my normal distribution, interquartile range will tell us the distribution or the range between the middle 50% of my data points. This will be my Q1 and this will be Q3. Moving ahead, let us find the interquartile range for the given distribution. As we have seen, to find interquartile range, we first need to find the quartiles. I divide my data set into 4 parts. This will be Q1, this will be my Q2, Q3 and Q4. My IQR is equal to Q3 minus Q1. It tells me this range. So my Q3 is equal to 87 and my Q1 is equal to 68. Subtracting these two, we get 19. So this is IQR or interquartile range. Moving ahead, another measure of variability is variance. The variance is the average of squared deviation from the mean. Variance is represented by the symbol sigma square. To find the variance, as the definition said, it's average squared deviation. So firstly, we need to find the square of deviation from the mean. Here, x is my data point. To find the deviation of my data point from the mean, I simply subtract the mean from my data point. Mu is my mean. I subtract it from the data point. Here I get the deviation from the mean. Squaring it, I'll get the squared deviation from the mean. Now I need to find the average squared deviation. To find the average squared deviation, I add up the deviation of all the data points and divide it by the total number of data points in the population. So I get the average squared deviation, which is equal to the sigma square or variance. In case of population, I take capital N, which is equal to the number of values in the population. But for samples, the formula is same. The only difference is that I divide it by the lowercase n minus 1, where n is equal to the number of values in the sample. Now we will see standard deviation. Standard deviation tells us on an average how far each data point lies from the mean. It's simply the square root of variance, as you can clearly see from the formula. It's represented by the symbol sigma. It's square root of variance. Here I can see that this is equal to sigma square. And if I take square root of this, I'll get similarly for samples. The only difference is I divide by n minus 1 in case of samples. Now let us consider an example to calculate the standard deviation. Here I am given with 5 data points. To calculate the standard deviation, I should first calculate mean. Mean, as we know, is represented by the symbol x bar or mu and is given by summation of xi upon number of data points. In this case, it will be equal to 1 plus 2 plus 3 plus 4 plus 5 by number of data points, that is 5, which is equal to 3. Now we'll calculate the standard deviation. As we know, standard deviation is represented by the symbol sigma and is given by square root of sum of squared deviation, that is xi minus mu upon number of data points in the population, that is n, which is equal to square root of what will be the first deviation or the deviation of the first data point from the mean. It will be equal to xi, that is 1 squared. Yeah, so it will be equal to 1 minus 3 square. I need to add up all the deviations, right? So the deviation of the second data point will be equal to 2 minus 3 square. For the third, it will be equal to 3 minus 3 square. For the fourth data point, it will be equal to 4 minus 3 square plus 5 minus 3 square, and I divide it by the number of data points, that is 5. On calculating this, I'll get my standard deviation as square root of 1 minus 3 is minus 2. Minus 2 squared, I'll get 4. 2 minus 3 squared will be 1. Plus 3 minus 3 is 0. Plus 4 minus 3 is again 1. So 1 squared is again 1. Plus 5 minus 3 is 2. So 2 squared will become 4. Dividing it by 5, which will become equal to under root of 10 by 5, which is equal to under root of 2, which will become equal to 1.414. So this is my standard deviation. Moving ahead, we have seen standard deviation and variance. Now we will see the interpretation of these terms. When we say my standard deviation or variance is low, in that case, we mean that my data points lie closer to mean. If my data points lie closer to mean, I can also say that the curve or the distribution will be steeper. As I can see from this curve, I can clearly see that this distribution is steep as the points are close to each other. This standard deviation is very small. That's why I'm getting a steep curve. But if my standard deviation of variance is high, in that case, my data points will lie far from each other. Or I can also say my curve will be flatter, as in this case, the standard deviation value is quite large. That's why my curve is flatter. But what do we mean when we say that our standard deviation and variance is 0? We have seen that variance or standard deviation contains average squared deviation. So by 0 standard deviation or by 0 variance, we mean that all data points are identical and they are equal to mean itself. That's why we are getting the 0 value. I hope you understood the interpretation of standard deviation and variance. If you liked the video, then please don't forget to hit the like button and subscribe the channel to get more such content to begin your journey in data science. Thank you.